Okay, this is AS Stats, and we're on Chapter 1, and we're going to take a wee look then at histograms. So, bar charts are not appropriate for data with grouped frequencies. A histogram is a diagram using areas rather than height of rectangles to represent frequency. It also differs in that the rectangles may have different widths. So the groups can be of kind of different sizes or different kind of group widths, which is one of the main things then about our histograms. So, advantages. We'll just write these, it might be a bit slow. It's good for distributions with different group sizes, obviously. I might rethink this. This takes a while to write. I'm just gonna, you can pause the video and I'll steal from my other sheet. That I did earlier. Hard to compare two sets of data, and we can compare it then to the normal curve. Disadvantage is it's hard to read off exact values. It's very hard to kind of tell what the frequency is just by looking straight at the histogram. Like the height of the bar in the bar charts. You know, if you kind of see a bar chart, you can see the highest bar is the one with the most, whereas that's not necessarily the case in a histogram. You lose the original data, and it can only really be used then with continuous data. So going ahead then and looking to draw a histogram. So the rule is that each rectangle area is proportional to the frequency. So you need to add 3 extra columns. We're going to do it in the next page here to your frequency table. Class boundaries, so be careful then with discrete and continuous data. The class width, we've just been through kind of questions like that. If you remember in the previous video, just doing these bits and pieces here. And then the frequency density, this is found by dividing the frequency by the class width. Generally, at A level, it tends to be frequency density. However, sometimes the frequency density is given as frequency density per 1 or per 2 or per 3. So just be careful then whenever you're looking at that. So if we go over the page, no, that's our page there. It says use a histogram to display the following data, which are the heights of model soldiers given to the nearest millimeter. So we need to get then our 3 new columns. So the first one is going to be class boundary. Our next one's going to be class width. And our next one then is going to be frequency density. So those are the 3 extra columns in that we need. If it was just a bar chart, we would plot that against that, but that's not what we have in this case. So if they've been measured to the nearest millimeter, then this could have been as low as 59.5 up to 65.5. So 59.5 to 65.5, 65.5 to 67.5, 67.5 to 69.5, 69.5 to 73.5, and then 73.5, then up to 75.5. That helps us work out the class width because we just take away these 2 values and that works it out for us. So 65.5, 59.5. If I'm doing this in my head, I secretly add a half to each and then it makes it easier. So if you add a half here, we get 60 and 66. So the class width then is going to be 6. 68 and 66, so it's going to be a 2. That's a 2. That one's a 4. And that's a 2. So how do we find our frequency density? We do the frequency divided by the class width. We've got quite big numbers here, so it's quite an awkward looking thing. So 126 and a third is what you get if you do 758 divided by 6. You get that. 937.5. 991.5. 897 divided by 4 is going to give us 224 and a quarter, and then 489 divided by 2 gives us 244.5. Up the side then, we're going to do frequency density, so we need to get our scale that goes as high as effectively 1000, and this fits in quite nicely. If h2 squares in as 100, that's going to fit in then for our frequency density. And then going along the bottom, we need to go effectively from 59 up to as far then as 76. So I've done then each square is 1 effectively, and it fits in quite nicely there. We kind of silly things you need to know from year 8 or 9. Put your scale in, put your label in, so it's frequency density here, and then heights in millimeters. So I have done this one previously, and let's take a wee look, and we'll just talk you through it. Hopefully this will make a wee bit of sense. You can see a kind of frequency density going up the side, and then we have that. Now things get a wee bit awkward here, but I've kind of started kind of 59 here. I've done the wee kind of squiggly line, 59, 60, 61, 62, 63, 64. So it's going up on ones as you go along here. Now here's your problem, and it seems wrong and it seems horrible to set it up this way, but each of these are all going to be half squares. So the first group goes from 59.5 to 65.5. So it's 59.5, so it's halfway along that square, and then 65 here, so 65.5 here, and it works out there. In these cases then, the areas represent the frequency, because it's frequency density going up the side then. So I can see, I mean, it's very hard to judge. Again, that was one of our disadvantages. It's very hard to see. I mean, this is going to be your biggest group. I know it is the tallest bar, but it is thinner, but the area of this one's the biggest, really. And works in from there, and you can do your different values in from there. So that's our histogram, and hopefully that makes sense and you can get that drawn then looking like that. Now, there are bits and pieces, as I said, where it's awkward. Those wee halves are really kind of tough. Shouldn't be any gaps in between, but that's the way the histogram looks for that. One of the things we had mentioned there, just back a page or two, is that it says in this example we could have used a frequency density or frequency density per 2 millimeters, as each of the class width then is a multiple of 2. If we use the frequency density per 2, our table would look like this. See these two columns here, they're going to be exactly the same, but instead of dividing by the group width, we're only really dividing by half the group width. Hopefully you remember from the previous one. I can just show you here. Anyway, this is 6, 2, 2, 4, 2. So if I sneak those in there, 6, 2, 2, 4, 2. If we're doing it per 2, you're not then dividing by the 6. You're only dividing by half of that. So you're going to be dividing by 3. So you would get 252 and 2/3. Dividing this then just by 1, so it's just 1875. Dividing this by 1, 1983. Dividing this by 2 is 448.5, and dividing this in by 1 should be, have I got that right? Is the size of that one? What's the size? 74 to 75. Yeah, dividing this in by 1 should be 489. And that's the way then they should look. You should get exactly the same thing whenever you actually plot your histogram. I know it seems a bit weird, just with a slightly different scale. So I've done this about here again. So instead of my scale going up to 1,000, you can see this time it goes up to 2,000, and it's exactly the same histogram. Don't worry about these lines. I'm going to explain that's a frequency polygon I've done on the top of it. And so it's exactly the same scale going along the bottom. It's the same, each of the bars are exactly the same height, but the scale has been done differently there, and that's where it would kind of make a slight difference. So you need to draw that one out. Again, you might want to pause the video and kind of copy this, but that can kind of be if it's frequency density then per 2 millimeters. Just to chat then about the frequency polygon, let me check and see just in case it's on the other side. Yeah, so on the other side of the page it says, if asked to draw a frequency polygon, join the points of the midpoints to each group with straight lines. Couldn't be more straightforward. You got each bar, you find the middle of the bar, do an X here, and join them up then with straight lines. So halfway along this bar, halfway along this bar, halfway along this bar, halfway along this bar, and that's your frequency polygon. Okay, notice the area underneath it is actually going to be the same as the area underneath area of the other shapes, and so we can use that for some other bits and pieces as well then.